Welcome to this ATA Insights webinar. Thank you for your ongoing interest and support of our webinar program. Today's session will begin in 2 minutes. ATA Insights Webinars is an online platform for the dissemination of professional renewable energy knowledge across international borders. Our aim is to democratize access to information, for innovation to spread faster, and to make the industry more competitive. And we do this through our online sessions, open to all our members. Every year we do more than 100 sessions with over 250 speakers, 50,000 attendees from more than 50 countries. To participate in the session today, use the chat on the right-hand side to introduce yourself, your company, or where you're joining from. Under the screen you will find the Q&A box, where you can send your questions for the speakers. We will get to as many as we can today. We're recording this session and we will send you a link to the materials in a few days. Please consider supporting our content creation for the webinar program. Contact us on the email on screen. Well, good morning, good afternoon. Welcome everyone to this online session about Repowering South Africa, how to develop PV systems for a more resilient future. I hope that you can join us today for the whole hour, where we're going to be talking to two experts on this specific topic. And I'd like to ask them to introduce themselves so that you can get to know them a little bit better. First of all, I'd like to ask Etalvina, please, if you can introduce yourself. Just take the mute. Perfect. Go right ahead.
Hi all, my name is Etalvina Cossa. I'm 24 years old and I have a degree in engineering and management of renewable energies. I have only 2 years of experience. I started as a project division assistant in Logos Industries, that is a South African company which does solar. And now I am the solar project engineer in Total Energies Mozambique.
Excellent.
Thank you.
Thank you very much, Etalvina. Nice to meet you. And she's going to give us the point of view of the developer, both in Mozambique and South Africa. And next, I'd like to ask Russ to please introduce yourself.
Yes, hi, Berlin, and thank you very much for allowing us the opportunity to be part of your ATA Insights webinar today. So I've been in the solar industry for about 10 years now. Initially, I was involved in tracker development in South Africa, and subsequent to that, I was involved in business development for the commercial industrial PV space. And as from January 2021, I joined GameChange Solar to head up their South African division, or their Southern African division, and looking at opportunities in Southern Africa.
Excellent. Thank you very much. So for all of you who are familiar with South Africa, which I'm sure most of you are, and I can see there are people here from South Africa, from Nigeria, from Denmark. We have people from everywhere, but a lot of South Africans and people from Botswana. South Africa is a country that relies very, very heavily on coal. And going forward, coal plants are coming to an end of life, and it is time really to move forward to a more decarbonized grid. And this is the case also for some of the other countries in Southern Africa. So today we're going to be talking about how PV projects can help part of that way. And what we're going to be doing today is very simple. We're going to be hearing first an introduction from Russ, then a presentation from Etalvina, and then finally a presentation also from Russ. And we're going to be talking about this topic specifically. So Russ is already preparing his presentation, and I just wanted to give you a little bit of housekeeping. We are recording this session, therefore you're going to have access to it afterwards. We'll send you a link where you can watch it again, and you can also peruse the materials that you see on screen. And I would ask you to use the chat to introduce yourselves, because we really love to see your messages and where you're from and where you're joining from. But for sending your questions, please use the chat box, the Q&A box at the bottom, so that they're easy for us to manage. We're going to aim to answer a few questions from the audience at the end of the session. So without further ado, I'd just like to ask Russ to begin your introduction, please. Go right ahead.
Yeah, thanks, Beline. So the topic of today's discussion, repowering Southern Africa and how to develop PV systems for a more resilient environment. So I think, what is kind of on everyone's mind is that what is the future of energy in South Africa? And as we know, for those of you who are in South Africa, currently we're sitting on a load shedding or rolling blackouts, as they're called globally, and that is purely because our current Eskom utility cannot supply enough energy. So as we speak today, we are on stage 4 load shedding, which means there's a deficit of 4 gigawatts that Eskom cannot supply. So there is an urgent need to, get things going in South Africa. And I'm glad to say that it's starting to open up now. So sorry, I'm just trying to...
Try the cursor, the arrows. No, that doesn't work. Okay, just if you come out and come back in, and let's try that. Sometimes we have issues with these things.
Okay.
It does happen.
Let's try again.
Yeah. And just make sure, yeah. Okay, go forward now for me, just before you start.
No.
That's strange. It's the first time I've seen it.
Okay.
Try the arrows at the bottom, no? There were some arrows at the bottom. This is the status. It does happen, guys. We try this all in advance and it all works. And then in your life, it doesn't. But hopefully, we'll sort it out. Otherwise, maybe we can show him. Okay, go now. Okay, let's try now.
Okay.
Oh, yeah, there we go. Perfect.
Yeah, got it.
Excellent.
Thank you. So I'm going to quickly give an overview of the regulatory environment in South Africa as it stands today. Just so that for those of you who are not familiar, have an idea of what's happening in the country. So up until about 6 months ago, any renewable energy plants within the private sector, and I'm going to start with the private sector because it's important that this sector is starting to open up. So as of about 6 months ago, any plant size under, I think it was 1 megawatt, or sorry, any plant size over 1 megawatt required a generation license. Now, that was changed last year, and it now stands at any project over 100 megawatts will require a generation license. So what does that mean? Well, it takes a whole bunch of red tape out of the process. However, there is still requirements that need to be adhered to. So one of those is approvals from the network service provider, whether that be Eskom or a municipality. We still have to comply with their codes and their grid connections, and one has to apply for that from the network service provider. The other requirement is we need to get still a registration process through NERSA, which is the National Energy Regulator of South Africa, and that has to be done in order to connect. So, as I said, it's a two-phase process. So the first is to get approval from the NSP, be that the municipality or Eskom. That time frame is plus minus 90 days, if you're lucky. It can take longer, but the general consensus is that that would be a 90-day process. Once you've got through that process, you then apply to NERSA to register your project. And that's another time frame of approximately 90 days. Now, whether they're going to stick to that 90 days is an unknown, but it is happening and projects are starting to happen. As I said, these projects must comply with the grid code in general, and one then would enter into a connection agreement with the NSP, the service provider. So there's still some gray areas from NERSA that need to be clarified, as this is a kind of a new process. There are a few projects that have gone through the process that are already in operation, and it's kind of a learning curve that we're going through in this country. And as more of these projects get, approved and on the grid, then, the learning curve becomes easier to connect, and hopefully it's going to start growing. So the main kind of sector that we're seeing within the private sector at the moment is mines, predominantly looking at putting in their own plants. With wheeling of energy being allowed, and there's still some gray areas here that need to be cleaned up, but one can build a plant in the Northern Cape, for example, and have an off-taker in the industrial area of Gauteng and be able to wheel that energy, which is facilitated through Eskom, through their grid company, which is now being taken out of Eskom and will be run out as a separate company. So it's a good thing that wheeling is now allowed, and it's going to open up the market to the private sector quite considerably. The other sector that has been predominant over the last few years is the government sector, and it has been a very successful process, what they call the REAP process. It's gone through several rounds. So these are generally projects over 100 megawatt AC. It's actually, 75 megawatt AC for solar PV. And it's done through a competitive bidding process known as the REAP process. So PPAs on these projects are entered into on a 20-year term with the state-owned Eskom utility. But the project procurement is driven by the Department of Minerals and Energy, as I said. So we have just received recently the results of bid window 5. But through the 5 bid windows, there's been 93 projects awarded, representing a total of 7.3 gigawatts of renewable energy, which includes approximately 4.9 gigawatts of solar PV, which is quite substantial. Further, there was the risk mitigation round, which was an emergency round, which there has been some delays with, but we hope that will get going soon. And in the risk mitigation, there's approximately 1.5 gigawatts of solar PV that will be going in. Now, it's important to understand that these risk mitigation projects are generation and storage. So all of them have a generation capacity, which would either be solar or wind. And added to that, they have either battery storage or gas supplement. And the reason for that is because the department required a constant supply from these plants from, I think it was 5 in the morning till 10 o'clock at night. So they had to bring in the storage, which is quite interesting for South Africa, because some of these projects on a global scale are quite big. I think one of them sits at around about 540 megawatts of solar alone with battery storage. So they are substantial projects. And these are supposedly being fast-tracked through the system, looking to be online by the end of 2023. I think there might be some delays, but that is the goal at the moment. And then REAP bid window 6 will be released end of March or beginning of April for a further 1 gigawatt of solar PV. Plus there will be a wind of about 1.3 gigawatts, I think. And thereafter, there's another 4 bid windows of 1 gigawatt each for solar. So that's according to the integrated resource plan. Whether there's going to be more of those or not, we're going to have to wait and see. So yeah, generally that's an overview of where the regulatory requirements are at the moment. If you do have any questions, please put them into the Q&A. And I'm now going to hand back to Eileen to continue with the process.
The session. Thank you very much, Russ. A very good introduction so that everyone can be open understanding what's going on in South Africa. Next, I'd like to ask Etalvina to please give your presentation. If you can take your mute off so that we can hear you. And then with that, we've already got your slides on the page. You can see them, correct, Etalvina? You can see the slides? Yeah, perfect. Yes. So just let us know when you want us to pass them forward. Thank you.
Okay, thank you. Hi all. When I first was invited to this webinar, I thought about preparing a whole slide with lots of information that I took in the internet, studies done by other people, and etc. But then I thought that it will be better to share with you what I have experienced in these 2 years of that I'm working in this industry. So it will be what I have seen, what I have experienced, and this is how I'm going to present to you. So I'm going to talk about the challenges in operating PV systems, how to implement cost-effective solutions, and best practices on solar. Can you please go to the next slide? Thank you. Talking about the challenges in operating PV system, I decided to put in 4 sections. The technical, economic, environmental, and political. Talking about the technical challenges, we see the reliability of the solar systems. When we are talking about the reliability, is the consistency of the production of energy, because we can see when we analyze a graphic, when we are monitoring a system, we can see that sometimes we have the peak, and then other time the energy just drops to half of its capacity, because we had a shadow because of the many things that may happen. So this is the reliability of the system. The difference from the other source of energies, the non-renewable energies, we have consistent production of energy, but in solar we don't have this, and this is a challenge that we have to see. We have to develop the technology. The other thing is the solar power efficiency. This is directly related to the reliability of the systems, but looking for the solar panel itself, because we lose the efficiency because of very factors, the temperature and the shadow. For instance, if you install a solar system, this is not, I don't recommend, but we see sometimes systems under energy lines and etc. So this affects directly on the efficiency of the model, of the PV model. The other thing that I see as a challenge, as a technical challenge, is the qualified workforce. We see many people that are installing PV systems, but they are not qualified enough. When we talk about qualified workforce, it's not just know how to dimensioning a system and how to put the solar panel. It's a whole process, starting with safety. We have to watch the safety of all of this work, to avoid accidents related to solar installations. We also have to look if the person is capable to see what is the best equipment for this area, because sometimes we have seen installations of companies, real companies that say, yes, we install PV system, but we see that they didn't use clamps. For example, they didn't use clamps on the PV system to fit the panel on the structure. So when we have when we have wind, we can lose some solar panels. And other challenge is the alignment with energy efficiency measures. Sometimes we can have a client that comes to us and say, I want to put solar energy in my house, but he's not using the measures of energy efficiency. He's using the old lamps. Their electrodomestics are not good. So we have to align the installation of the solar system with energy efficiency measures, so that we can avoid dimension big system when we can dimension a system that fits in this house. The other area is the economical area. One of the challenges is the acquisition cost. I think this is clear because we see that the system are not cheap. So especially when we have batteries, they increase our cost of this investment. So 40% just on batteries. And the return of investment, that we have long periods of return of this investment for houses, for simple houses. When we're talking about industry, just it's a little bit different. The other area is the environmental. Now we think about the solar panel production. The production of the solar panels, that the emissions, the type of energy that is used, how much emissions we have when we are production solar panel. So do we have how can I say, equilibrium with the two parts? We are production solar panel to avoid pollution, but to produce this thing, we are polluting the environment. So this is the question. This is one of the challenges. And also the production of the batteries, and also the recycling of the batteries, that it's a huge challenges in this industry. Another area that I have identified is the political. Some or many of the countries in Africa don't have a clear regulation about the solar systems. I will give an example of Mozambique, where I'm based. We don't have a clear regulation on energy of renewable energies. Now we are starting to look to this component. We have some credits, and that we are trying to regularize this industry. But for example, we are not allowed to inject energy in our grid. So if you have an on-grid system, we have to check if it's zero injections, because we are not allowed, and you have to dimension it very well. You cannot sell your energy or even just inject to the grid. Can you please pass to the next slide, please? Okay, thank you. Now going to cost-effective solutions. There is a note here that say that overall PV systems are seen as a cost-effective solution for business. It's cheaper to use the solar energy instead of the conventional energy. We have some example here in Mozambique of a company that decided to install, is not solar, but they decided to install their own electricity source instead of using the conventional electricity source that is our provider of energy here in Mozambique. So in this cost-effective solutions, we have two blocks, that is the technology and the planning. Why I'm talking about the planning? Because when we plan, we avoid high costs. For example, if I know that I'll have to install a solar system in January, I have to start planning it in June, because I have to count with the time for acquisition of the equipment. So, for example, for transport, if I have my planning done properly, I will have I'll save my cost of transport, because I have time and I can opt for the sea transport that is cheaper than the air transport. And we have the case of batteries that are a dangerous equipment. They cannot be transported by air, so are just by sea. And then you have more cost in your project if you don't plan it well. Even the transport in your country, you have to see the ways, the type of transport to use. You have to look for the labor here in your country, and etc. Technology, we have to use the most advanced technology to have these cost-effective solutions. Now the market is transitioning from polycrystalline solar panels to monocrystalline. They are more efficient, and then you have more power in your panel that can, how can I say, you have more power in your panel, and you have paid for this instead of paying for one panel that you cannot have 100% of its capacity. We have also another technologies as trackers of the sun. We have these solar panels that follows the direction of the sun. We have the lithium batteries that they are very, they cost a lot, but they have lifetime of 25 years, 20 years, 15 years, instead of the acid batteries that they have 2 years, 3 years of lifetime. We can go to the next slide. So here, hi.
Yes, hi.
Can you hear
We
me?
lost you there for a second, but you're back now. We've lost you again. Are you there, Etalvina? Etalvina? I can see that you're talking, but we cannot hear you. Can you talk for us? Okay. I'm not sure. Okay, now we hear
Can you hear
we
me?
hear you. Yes, yes. Go right ahead.
Okay, thank you. Sorry, it was the internet connection.
Yeah, I understand. It happens the same to all of us. Go right ahead, Etalvina. Let's see if we can squeeze a few minutes more out.
Okay. Now that I'm back, we'll talk about the best practices on PV system, on the implementation of PV systems. Here I have divided in 3 areas: the studies, installation, and commissioning. We have this first stage of the project that are the studies, so that we can start purchasing our equipment and then going on to the installation and commissioning. So in the studies, first we have to measure the electricity consumption of the site so that we can dimension it well. What I have seen in my experience is that some people just asked to the client, how many lamps you have, what is the power of the lamps, how you, which equipment do you want to use the solar energy, and this is not accurate enough. You have to at least put a device that measure the electricity consumption of the site for at least 15 days, so that you can have the behavior of the consumption of this site. Then another important component is the structure analysis. You have to ensure that your roof, if you're going to put the solar panel on the roof, you have to ensure that this roof can handle the weight of the solar panels, and not just the solar panels, but the structure and the people that are going to be working in this installation. Because you cannot just look into the weight of the solar panel, as you are going to have people, big men, at least 3 men working there, and this is weight. You can lose your roof. So this is very important to make structure analysis to avoid these risks. Then you identify the typology of PV system to be installed, if it is on grid, if it is grid tied or off grid. Then you ensure the correct dimensioning based on the measurements. I already talk about this. Identify possible opportunities to implement the energy efficiency. If the person does not implement this energy efficiency, you see the consumption of the site, and then you tell, okay, you can reduce your consumption here, and here, and then you dimension your your PVC system based on this new reality of the site, and identify the most suitable equipment according to the site. You have to see the location of the site so that you can choose your equipment. For example, if you are making a solar system near to the sea, you're not going to use the same equipment that you could use in a solar installation far from the sea. So this is very important. For instance, you can use components that meets the IEC 61215 for weather resistant. The installation is another area. We have to ensure safe access and circulation to the work area. This is safety, to ensure you have the ladder to access the roof. If you have safety points that you can anchor your harness so that when you fall, you don't fall to the ground. You are secured. And then install all the equipment as per the project and the manuals. It's very important to ensure that the equipment is well installed as per the manuals and the project. For example, the connection of the strings of your panels. You have to look before connecting to your inverter. Then we have to ensure the correct cabling, including earthing and including the earthing of the system. Sorry.
You okay, Etalvina?
So sorry, I just had to answer my colleague. To ensure the correct cabling, including the earthing of the system, to ensure the installation of an emergency stop button and signage. This is very important because if you have a failure in your solar system, you can protect other equipment if you have this emergency stop button. Signage so that people can see that here we have DC cable and this is the inverter and this is dangerous, so that people can know that they cannot touch this equipment. And ensure the installation of critical equipment such as batteries and inverter in a well-ventilated area. In the commissioning, first we have to measure the open circuit voltage of the strings to avoid damage in the inverter. In some cases, we have the trackers, the MPPT inside the inverter, so we have to avoid connecting the strings without measuring the voltage. And the system have to be started by an authorized person. You have to certify that there is no hotspots in your electric board. Connect the installation to internet to guarantee monitoring. This is very important so that you can see how your solar system is behaving, and check the zero injection for countries that are not allowed. This is all from my side. I hope you have learned something with me. I hope to learn something with you soon. And thank you for listening to me. And I give my word to Bennett. Thank you.
Thank you very much, Etalvina. Very, very detailed account of all the things that you need to watch out for. Thank you very much for that. And Russ, like I send it back to you. Let's just try when you share that. Let's make sure that it works this time. And so that Etalvina, there is a bunch of questions in the Q&A box at the bottom. If you want to have a go at them by text, feel free. We'll be delighted. If not, we'll try. We probably get 10 minutes at the end, hopefully, to answer some of the questions. Russ, go right ahead and share.
Yeah, thanks, Pauline. Let's try that again. And let's run this.
Let's see. Oh, you have an Apple Mac. Yeah, that's why. Zoom and Mac,
Yeah,
I don't know why.
You caught me out there.
So keep going forward to the next, just to make sure that it works. Can you move it? Yeah, perfect. Yeah. Okay, there we go.
Good, we got
Excellent.
it.
Thank you.
All right. So yeah, thanks for getting back to me now. So the next question in the presentation is, how does a tracker manufacturer ensure that its product gives the project developer or investor a superior levelized cost of energy? So I think to those who are not familiar with GameChange Solar, a quick overview of what GameChange Solar is. So GameChange Solar is a racking and a tracking manufacturer. We're a global entity. We probably sit at number 4 in the USA market, and we're currently sitting at number 6 in the global market. So we are a big company. We have supply chain, a global supply chain, and we do some big projects globally. But purely, as I say, supplying racking and tracking. We don't get involved in building solar farms for ourselves or other parties. We purely supply the equipment. So how do we ensure that our product gives the project developer or investor a superior levelized cost of energy? So number one, superior engineering, design, and innovation drives tracker equipment costs lower. So we find we need to continuously improve our designs. We have to continuously innovate, and we have to continuously try and reduce costs, because as a lot of you guys out there might know, these big projects are a cutthroat project. The developers and the EPCs are trying to squeeze everyone for a low price. And that is always a challenge, because at the end of the day, we have a situation where the price of steel has gone up dramatically over the last year or so. Price of shipping has gone up dramatically. So we constantly look at ways of reducing the amount of steel we put into these projects and innovating to ensure that we're ahead of the game. We look at reducing manufacturing costs by simplifying the designs, and that is a constant involvement that goes on to make sure our trackers meet those simplified manufacturing costs. We have to ensure that the trackers are easy to install, and we have to ensure that the maintenance costs of the trackers is kept to a minimum as far as we can, because as you can imagine, no one wants to go and spend capital on installing a tracker that, number one, needs a lot of maintenance, and number two, might not be that reliable. So just to go on from there, how do we reduce the cost? We leverage our purchasing power through our global supply chain. So we have manufacturing capacity in the USA, in Middle East, in China, in India, and now in South Africa. So we look at how we can, because of the vast amounts of steel we are purchasing, how we can leverage that through our suppliers. And we constantly talking, to the steel mills, to big manufacturers that we partner with to manufacture our products. So we don't invest in our own manufacturing facilities. We partner with companies that can manufacture. So we don't have wasted infrastructure that might not be working. And we rely on superior partnerships to manufacture to our quality requirements, and we always make sure that those quality requirements are met to ensure reliability and a good lifetime, for our products. So another innovation we have is a topo engineering design optimization. So we'll take a topo of the site, we'll take it into our system, and we will design for that site. So what this does, it reduces the cost of earthworks at the end of the day. And it tells us where we might need to do small amounts of earthworks, but it really is a great cost saver, when it comes to building these big plants, that, the guys don't have to go in with heavy machinery and, level the site. We can pretty much work, and particularly, in projects in the Northern Cape where the ground is relatively flat, but it might have a few ups and downs. That topo engineering is very useful to reduce the costs. One of our other innovative products is a product called Weather Smart. And basically what this does, it monitors the sky with sensors, and it kind of understands on a cloudy day where the best position is, for the tracker. And that will increase the production up to 1.25% overall. So it's an innovation which not a lot of guys use, but it is being used successfully in places to, eke out that extra production from your solar modules. And then, as I intimated earlier on, the ease of installation is very important. So we have some innovation things, and one of those is a product called a speed clamp, which is a product that increases decreases the installation time of your solar modules. So it greatly helps bringing down the cost of module installation. It's a very quick and easy method to clamp your modules onto your torque tubes or onto your frames. Another innovation we have is supplying pre-assembled components. So some of those pre-assembled components that require precision assembly and torquing, we do those in the factory, and we deliver those pre-assembled components onto the site, which again reduces installation times and risk of construction errors. Because, if there are construction errors, and let's say, for example, you're building a 100 megawatt plant, and the guys on site, have an error, and they, start putting modules on. You can imagine it's quite a costly exercise if you've got to take those modules off to make a correction. So, we're ensuring that by doing the pre-assembly, that we reduce that risk of construction errors. And then the other big thing is reliability. If a guy's putting in, a developer or an investor is putting in a tracker, they really want to make sure that that product is reliable. So we undergo accelerated mechanical life testing, equivalent of 40 years. And our actuators and bearings are designed for a maintenance-free lifespan of 40 years. Now, I'm not saying things don't go wrong, because things do go wrong. You might get a lightning strike that takes an actuator out, or takes your electronics out, and you have to replace it. And I think importantly, the replacement of those components that might get taken out is very quick and easy with our tracking systems. So yeah, overall, we are trying to ensure that as a whole, our systems reduce the levelized cost of energy. Right, then going on to the next slide. Question is, learn from manufacturers how new trackers are adapting to cover market needs and improve the productivity of solar generation projects. So, as I said earlier, it's a cutthroat business. We're constantly being squeezed, and developers are constantly trying to get more bang for their buck. And they want to know how they can do this. So we are continuously improving the design of our products. And we're forced to do this because module manufacturers constantly changing sizes of modules, bringing out bigger modules. They are reducing the strength of their frames as far as they can, and they push that reliance onto us to ensure that the modules are secured, properly onto the frames and onto the purlins, and that they don't have under big wind loads, they don't have structural failures. So we are constantly working with module manufacturers to ensure that our systems are approved for mounting of the modules. As part of this process, we are frequently doing wind tunnel testings for new modules and coming out with new design concepts that we test, in the wind tunnel. So that's an ongoing process, which is a constant ongoing process. Furthermore, constant engagement with module manufacturers to ensure that the mounting structures that we build are approved by them. That's very important because at the end of the day, if a developer, mounts a whole bunch of modules and you have a big windstorm that comes through and strips those modules off and causes an amount of damage, you want to ensure that you have backup from the module manufacturer, that the systems you're using to mount their modules are approved by them. So another way we're looking at is constant development of innovative products. So we, have a think tank going all the time, and we're looking at innovative ways to reduce costs on our trackers. Reliability. So big thing for us is reliability and uptime. We need to ensure that our trackers run, without breakdowns as far as possible, and that if there are breakdowns, that we give the support to our installed products, to the developers, that we will try and get that tracker back up and running, within the shortest period as possible. So big thing for us, reduce downtime and ensure that our products are running, as close to 100% of the time as we can possibly get them to do that. So yeah, that is then the end of my presentation, Beline. Thanks for that, and thank you for the audience for joining us today, and we look forward to being able to answer any questions that you might have.
Thank you very much, Russ. I'm going to ask you to stop sharing so that we can see the two of you more
Yes.
larger. Perfect. And feel free, please, to take a look at the questions. If you like to ask to answer any specifically. I do have a few questions that I like to ask now, and then we can take it from there if you want to answer any others that are there. I see there is a lot of questions here about different battery systems. Thing is, like, in this specific panel, we don't have experts necessarily in battery systems, so I'm not sure to what extent, these are questions that our experts are going to be able to answer, so that but we do have a lot of events sometimes that, specialize in batteries and, in recycling and whatnot, because I see there is a lot of interest, and there are important questions to ask. I'm just not sure that this is the right event for us to answer them. So I just wanted to mention that, because I wish I could ask some of these questions, but I think that we need to have a different forum for us to be able to answer them. So one of the questions that I want to ask, and this is specific for Etalvina, but also feel free, Russ, to add. Some of the questions that repeat themselves quite a lot is about the difference between off-grid and on-grid solar systems in terms of cost, the energy that they provide, and accessibility. So can you give us, a comparison, so to speak, in terms of how affordable on-grid and off-grid can be for people? If you can take your mute off, Etalvina.
Okay, thank you. As I said, on off-grid systems, the huge difference is that we have batteries, and batteries may increase your cost to 40% percent of your investment. The huge difference is that on grid systems, you have your power production when you have sun. We consider 5 hours of isolation. So you have 5 hours using your solar system. And also there is one thing that you are, how can I say, you depend on the grid energy because your inverter needs to have a reference of levels of frequency, voltage, because we know that the voltage that we use on our appliances is not the same voltage that we are getting from solar. So the inverter needs one reference. If you don't have the generator, your only reference will be the grid. So when you have a power cut on your grid, you also don't have your production on the solar. Your inverter turns off because he doesn't have the reference so that you can have your solar production. And on off-grid systems, you have high costs of this project because of the batteries, but you always have your PV system running, despite of the weather and etc. You have your energy in the day, you are using your energy, and also you are charging your batteries to use at night. And if you have a power cut, your inverter will not turn off because he has the reference on the batteries. So he will take the energy that you have in your batteries and give to your appliances. This is one of the biggest difference on grid and off-grid systems. So for people that live in the system, in the city, I would recommend on-grid systems so that you can use in the day, especially on the offices that we have this electricity consumption in the day. You can use on-grid system, but in the rural areas where you don't have the grid, you can only use the off-grid systems. Is your only solution. But for this requirement, you have the solar home systems that are small systems which use battery, solar panel, but only can supply energy for small appliances. Thank you.
Excellent, Etalvina. Thank you very much. And a question for you, Russ. Let's say there are a lot of developers in the audience that are considering whether to deploy a tracker, or whether to use a basic structure. Like, what should be the guiding principles in terms of choosing a tracker over just a structure?
Yeah, thanks, Pauline. So I think it comes down to what is the return on your investment. So, if we look at a tracker, what advantages does a tracker give you? So, roughly you're probably looking at probably about 8% plus CapEx spend for a tracker as opposed to a static racking system. So, we need to take that factor into account. But what we need to look at is obviously what return does that give you? Now, in Southern Africa, in a good sunny region like the Northern Cape, with a tracker, you're probably going to get about 22 to 24% more energy from your system. So, 8% more CapEx spend, 24% more energy, it's a no-brainer. But one needs to work those numbers, and you need to see where, through running a PV system model or whatever on a particular site, you need to look at those returns and make the assessment as to what is going to be the beneficial option to go for.
Thank you very much, Russ. And another question, apart from the 2 regulatory registration process that you highlighted, what other permitting requirements are required to ensure that a project is shovel ready?
Yeah, sure. That's a good question, and perhaps I should have covered that. So, I think it's important for anyone looking, at a development to understand what has to be done. And, in South Africa, like I think in most countries, prior to making those applications with NERSA or with the network service provider, one has to go through a comprehensive environmental impact study for any particular site. Number one. And number two, you would need to get authorization for that particular land use from the local authority involved. So, that process could take a year or more, could take 18 months to go through it. But it's important that in South Africa, our departments do require a very stringent EAI process needs to be followed.
Excellent. And just one more question, then we're going to have to go because it's already 12 o'clock. Do you guys have at GameChange, at Game Solar, your own SCADA system?
No, we don't have our own SCADA system. We have our own monitoring system for our trackers. So that monitors the status of the tracker, the position of the modules, battery power, etc. But that data is all available, to a developer or to a project construction company to integrate into any SCADA system. So it's all open source, and we give that support, to the developers to be able to take that data into their SCADA and include it in their reporting structures.
Excellent. Well, thank you very much, Russ, and thank you very much, Etalvina. It's been a very interesting session. And, I think Russ was the one that said that this is a cutthroat business. It is a cutthroat business indeed, but it is by being cutthroat that solar PV particularly has managed to get down costs incredibly over the past 10 years or so. And it looks like going forward, this is where it's at. We're still going to be competing very much for scratching, the cents from the cost of the plants and making sure that the LCOE is a lot more competitive each time. This is particularly important in certain markets where the price of energy is a very sensitive matter. So I think going forward, it is important to pay heed to all of this advice that you heard today from Etalvina and from Russ as to how to make sure that your calculations for your PV projects, are next level, and you're scratching, at those percentages, at those little things, at those increases in efficiency that make sure that the next time around, your project is still the most competitive. So thank you very much, Russ. Thank you very much, Etalvina. And thank you very much, everyone in the audience. And we will see you next time. Thank you.